Hello everyone, this video is about velocity time graph. We are gonna analyze it to learn about all properties of this very important graph in kinematics. In this video you will learn about number 1, direction of motion on VT graph, number 2, speed time graph out of VT graph, number 3, speeding up or slowing down motion on VT graph, number 4, slope of VT graph, and the last is displacement and distance on VT graph. Are you ready? Let's start. Number 1, direction of motion. Suppose that this VT graph is indicating the velocity time graph of an object moving on x-axis, straight line motion on x-axis. The initial velocity is positive 3, means that at t equals 0, the object is moving to the positive direction of x. Positive direction of x. Here also the velocity is 6. Here the velocity is something, but it's positive. So from t equals 0 to t equals 9, the velocity is positive because the VT graph is above the t-axis. So the object is moving to the positive direction of x. Positive direction of x. At t equals 9, it stops, and then because the velocity is 0, and then changes direction because the velocity is negative after that. Basically, at t equals 9, we can say we have a turning point at which the object will change the direction of motion. So from t equals 9 to t equals 16, the velocity is negative because the VT graph is below the t-axis. Let's say the turning point is here. Means that from t equals 0 to 9, the object is going to the right, it stops here, and then goes back. That's all. This is the meaning of turning point. So, let's summarize it. When the velocity time graph is above the t-axis, velocity is positive. When it is below the t-axis, it's negative. And when it crosses the t-axis, means that the object is changing the direction of motion, turning point. Let's continue. Number 2, speed time graph. You know that the speed is magnitude of velocity. When I say speed, when I say velocity, I mean instantaneous speed, instantaneous velocity. Okay? When the velocity is positive, we have no problem. Actually, when the velocity is positive 6, also you know that the speed is 6. That's all. But when the velocity is negative, like negative 5, the speed cannot be negative. It's absolute value or the magnitude of velocity. So it must be positive. So what should I do here? Mirror image is the best. Let's put a mirror image. Suppose that this negative part is going to be downside up. Make a mirror image on t-axis. This is exactly the mirror image. So from now on, it's going to be a speed time graph. That's all. It's very easy. Let's continue with a very important point. It's the good opportunity to learn what the speeding up or slowing down motion is. Speeding up means increasing the speed. Slowing down means decreasing the speed. Look at the graph from t equals 0 to 4. You see that the speed time graph is escaping from t-axis. Actually, the speed is increasing from 3 to 6. So it's going to be a speeding up motion. When from 4 to 9, when the graph is getting closer to t-axis, it's going to be a slowing down motion because the speed is getting decreased. Here it stops and then again speeding up and then slowing down. That's all. So when the speed time graph is getting closer to t-axis, it is slowing down. When it is getting further away from t-axis, it is speeding up. That's all. It's very easy. Okay. Number 4 is a slope or gradient. The slope of VT graph, I mentioned in the previous video what the acceleration is. It's exactly the acceleration. So instantaneous acceleration. So when the VT graph is increasing, better than that, when it is ascending, the slope is positive, we can say the acceleration is also positive. At the peak point, maximum or minimum, acceleration is going to be 0, then acceleration is negative because the VT graph is descending. So again, the acceleration is negative. Even at t equals 9, the acceleration is negative because the slope is negative. Here again, at the bottom point, the minimum, the acceleration is going to be 0, and then acceleration in ascending part is positive. That's all. Just to remind you something from the previous lessons, you know that according to the Newton's second law of motion, F equals ma. As the mass is always positive, so whenever the acceleration is positive or negative, the force is positive or negative. For instance, here, as the acceleration is positive, the force acting on the object also is positive. So the object is pushed or pulled to the positive direction of x. And when the acceleration is negative, also the force is negative. So the object is acted by a force to the negative direction of x. Okay. Number 5 is displacement and distance. Pay attention, it's very important. Let me change the color of this pen. Yeah, it's better, I think. From 0 to 9, you see that the velocity is above the t-axis, okay? The area under the graph for VT graph indicates displacement or distance, but you should be very careful about that. Let's say the area under the graph, the area confined between the graph and the horizontal axis, the t-axis, here is measured to be 10. And then the area under the graph here is measured to be 6. Basically, 10 means that the object displaces for 10 meters to the right, positive direction of x, and then 6 meters to the negative direction of x. Okay, so the area below the t-graph indicates the negative displacement, above the t-axis, positive displacement. So for finding the whole displacement, I can say delta x, the displacement is going to be 10 minus 6, which is 4 in this case, 4 meters. But for finding the distance traveled is different from displacement. I should measure the total length of the journey. Actually, it's not important for me that the object is going to the negative side of the x-axis. Basically, I should add them up to find the distance. So let's say distance traveled is 10 plus 6. So it's 16 in this case. It's very important. So keep in mind, distance or displacement both can be derived from VT graph, depending on your choice. If you are going to find the distance traveled, you should add them up. Let's say it is S1 positive. Let's say it's S2 positive. Distance traveled is going to be S1 plus S2. But if you are talking about displacement, it is different. It's going to be S1 minus S2. You should subtract the area below the t-axis from the area above the t-axis. You may have a question. Is it possible to have a negative displacement? For instance, let's say the VT graph is like this. Actually, the area above the t-axis is small and below the t-axis is large. Yeah, why not? Here, let's say S1 is 10. And let's say here S2 has a value of 30. So what should I do about the distance traveled? Distance is 10 plus 30. It is 40. Displacement, pay attention. Displacement is 10 minus 30. So it's negative 20. Yeah, it could be negative. It's very important. Now, if you are ready, let's have some problem solution to learn it better. An object has the VT graph below. Find part A, acceleration, and part B, average velocity and average speed in the first 5 seconds. Pay attention, I want to emphasize again, we are all in the context of straight line motion, so let's say always the object is moving on x-axis. Okay. To find the acceleration, we know that acceleration is the slope of VT graph, and as the VT graph is a line here, so the slope is the same everywhere. So don't bother yourself to check a certain part of that. Just you have to establish a triangle like this and then rise over run, or height over base. Height is 10 and base is 2. So 10 over 2 is going to be 5. The slope is 5 but negative 5. It's very important because the velocity time graph is the descending line. So acceleration is negative, let's say acceleration here is negative 5 meters per second squared. Okay, now let's continue. Let me write it again. Acceleration negative 5 meters per second squared. Let me continue with average velocity and average speed. You know that average velocity is delta x over delta t. Delta x is the displacement, and average speed is going to be the distance traveled over delta t. Okay, what should I do here? It's not that complicated. I can write it like this. Let me find the area under the graph for both. Here, the area is the area like a triangle, and height times base over 2. So the area here is 10 times 2 over 2, which is 10. The area under the graph here is 15 times 3 over 2. Pay attention, the vertical is 15 and the horizontal is 3, so 15 times 3 over 2. Let's say it is 45 over 2, that's 22.5. Okay, now let's find the delta x. Delta x is the displacement. So displacement is 10 minus 22.5 over delta t, which is 5. That's all. It's going to be negative 12.5 divided by 5. To find it, you can multiply both numerator and denominator by 2. It's very easy. Now it's going to be 25 over 10, which is 2.5 meters per second. But negative, it's very important. Why the average velocity is negative? Because delta x is negative. Means that the area below the t-axis is larger than the area above the t-axis. About the s-bar, the average speed, it's not that complicated. D is the distance traveled here. So the distance traveled is 10 plus 15. It's very easy. You don't have to pay attention to any negative sign. So it's 10 plus 15 over total time. Delta t is 5 here. So it's going to be 25 over 5, which is 5 meters per second. Average speed cannot be negative. Speed cannot be negative. So it's always a positive value. But you know that the average velocity is very, very critical. Sometimes it can be negative, sometimes even 0. When suppose that the area above the t-axis is equal to the area below the t-axis. So the total displacement is 0. So we can report the velocity, average velocity to be 0. Yeah. Okay, let's continue. An object has a sinusoidal VT graph below. You see the velocity starts from 0, goes up to 8 meters per second, and then goes down to negative 8 meters per second, and then stops at t equals 4. In which moments acceleration of motion is 0? Guys, you know that acceleration is a slope. When the slope is 0, you are at peak points. Here, acceleration is 0. Here, acceleration is 0. So it happens at t equals 1 and t equals 3. Part B. Do you see any turning point? Yes, of course we do. Here, the velocity is 0 at t equals 2. Before that, velocity is positive. After that, negative. You know, when the VT graph is passing through the t-axis, crossing the t-axis, we know that we have a turning point. Part C. How many seconds it is speeding up? For speeding up, you have the first alternative to draw the mirror image of the part below the t-axis, you know. Forget about here and then make it inverted, okay? So this is a speed time graph now. When the graph is escaping from t-axis, here, speeding up, here, speeding up. So 1 second here, 1 second here, totally 2 seconds, okay? The other alternative, which may seem easier, I think, it's just checking the speeding up or slowing down on VT graph. When the VT graph is escaping from t-axis, it is speeding up, that's all. So here speeding up and here speeding up, escaping from t-axis. 1 second here, 1 second here, totally 2 seconds. Okay, that's it. In the VT graph below, find part A, acceleration at t equals 1, and B, average acceleration from 0 to 4. Okay, you see that the VT graph starts from 0 and it's linear to t equals 2. Then it has a different slope. So acceleration is different here. I see two different accelerations. Let's say it's acceleration 1 from 0 to 2 and then acceleration 2 from 2 to 4. Okay, t equals 1 is part of the first line. 1 is here, somewhere between 0 and 2. So at t equals 1, or every second between 0 to every moment between 0 to 2, acceleration is the same. It's a1 because it's a line. So let's just consider the slope of the graph from 0 to 2. It will be exactly the acceleration at t equals 1 also. I establish a triangle again. Rise over run. Rise is 10, run is 2, 10 over 2 is 5. So acceleration is 5 meters per second squared at t equals 1, and also every moment between 0 to 2 because it's a line. But part B is different. Guys, pay attention. Part B is very critical. Average acceleration from 0 to 4. You remember, average acceleration was v final minus v initial over t final minus t initial. Look at the whole motion. Final moment is 4. And velocity at this point, final velocity, is going to be 5. So it's 5 minus initial velocity is the velocity at t equals 0. So it's 0. 5 minus 0 over 4 minus 0. It's very different from instantaneous acceleration. Seems to be 5 over 4 meters per second squared. Okay, this lesson also finished. Thank you very much for being with me. Take care and don't forget to review the lesson. See you in the next video.